AI analysis. Everyone can realize that internal combustion engines are completely free from emissions problems, but only current piston engines with many emissions problems. Because the Rotary Piston's engine in general and Nguyen's rotary engine in particular, with the outstanding features of this innovative design, is to use a coaxial rotation mechanism by the maximum 100% tangential impact force with the total inertia force continuously and directly. The improved fuel efficiency directly results in very low fuel consumption of only 30% of that of today's piston-engine passenger cars and reduced emissions per mile driven, benefiting both the environment and consumers. Furthermore, when using hydrogen fuel, or CNG gas, CO2 emissions are automatically zero when using fuel with hydrogen or natural gas CNG, LNG, and LPG. Advanced rotary piston gasoline engines, through a combination of innovative design, optimized fuel blends, and compatibility with renewable resources, provide a path to significantly reducing the environmental impacts traditionally associated with internal combustion engines. Continued research and adoption of these technologies is essential to maximize their environmental benefits. We can consider the benefits of rotary piston engines versus electric vehicles as follows. 1/Electric vehicles have higher initial investment costs than gasoline vehicles, especially due to the cost of batteries and related technology. The average price of a new electric vehicle is usually about 72% higher than the average price of a new gasoline-powered vehicle today, depending on the type and brand, due to the more expensive battery and electric motor technology. 2/Monthly operating costs are not low, including charging and maintenance costs, of which the cost of charging is much lower than gasoline today, but the cost of renting or replacing batteries is a big factor. Nguyen's rotary piston engines with high efficiency and performance have very low monthly operating costs, only at 30% of current piston engines. 3/ The battery is the most expensive part of an electric vehicle. The price of replacing the battery is high, with an average life of 8 to 10 years. Replacing the battery is a major expense when using an electric vehicle for a long time. Even when researching and developing batteries with high specifications, the cost is even higher. For the rotary piston engine, according to Nguyen's design, the maintenance cost of mechanical parts is small and very low. 4/ Limitations on charging time and travel range of electric vehicles. Electric vehicles, EVs, have made significant progress, but the main limitations related to charging time and travel range can hinder their convenience compared to traditional gasoline vehicles. Real-world inconvenience. Many electric vehicles fail to reach EPA-estimated driving ranges in real-world conditions. Consumer reports found that about half of the EVs it tested fell short of their advertised range, sometimes by as much as 50 miles. The impact of using auxiliary power for heavy use of auxiliary features can further reduce effective range, sometimes reducing the promised 300-mile range to 170 miles or less. Uncertainty, combined with limited and sometimes unreliable public charging infrastructure, leads to range anxiety for careful driving. Inadequate charging networks mean that finding a charger, especially outside of major metropolitan areas, can be a major challenge, sometimes untimely and time-consuming. Completely helpless when unexpected travel needs arise that exceed the immediate capacity of the battery and charging station compared to traditional vehicles, making it impractical for everyday use or long trips. AI analysis. Not fully meeting consumer expectations for convenience like gasoline cars, with public charging stations as accessible as gas stations and driving ranges in excess of 310 to 400 miles per charge.
Electric vehicles do not meet the expectations of users for fast charging and long driving range, but there are significant limitations in everyday convenience. Electric vehicles are not as convenient as gasoline vehicles, with charging stations and driving ranges do not exceed 310 to 400 miles per charge. It is obvious that the current range capabilities of electric motors are completely inadequate for long-distance sailing on the sea and on rivers. This is a huge demand in the maritime and waterway transportation industry. gasoline, or hydrogen engines, simply take a few minutes to refuel with fuel consumption calculated as your car will use 7.77 liters of gasoline per 100 kilometers. So when filling 64 liters of gasoline, the current piston engine will travel a distance of 800 kilometers, 500 miles. But with the high efficiency of MINH'S rotary engine, it will travel a distance of 2,400 kilometers, 1,300 miles, with a cost of only 64 liters of the gasoline, meaning 2.7 liters of the gasoline, 100 kilometers. On the other hand, with powerful and compact engine materials and design, it greatly reduces the overall weight of the vehicle, helping to improve fuel efficiency and reduce total emissions per mile traveled. In short, the high cost of electric vehicles mainly comes from the cost of batteries and the cost of replacing batteries when they reach the end of their life, along with the operating and maintenance costs not lower than the Nguyen's rotary engine. The cost of batteries is a large investment and needs to be carefully considered when using electric vehicles for a long time. Moreover, the Nguyen's rotary engine operates with very obvious mechanical principles that are a solid basis for calculating the engine's statements as presented above. 1. Superpower. The thrust, explosion, of each 3-pole piston's pole is maximum and complete with a long gun barrel effect that has a time to explode and completely burn fuel thoroughly, leading to lower fuel consumption, but creating a very large explosive force that impacts the maximum torque of the machine shaft on each continuous 120 degrees rotation angle. Direct fuel injection and stratified combustion optimize the air-fuel mixture, resulting in a more complete, cleaner, and more efficient combustion. This results in lower emissions of carbon monoxide, CO, hydrocarbons, HC, and particulates, as less fuel is wasted and less unburned hydrocarbons are released. Emissions of pollutants such as nitrogen oxides, NOx, sulfur dioxide, SO2, and particulate matter are reduced. These reductions contribute to improved air quality and a very high, very positive environmental impact, meeting the requirements of world emission standards, and with zero CO2 emissions when fueled with hydrogen or CNG gas. Increased engine performance, but reduced fuel consumption, resulting in lower emissions per mile driven, benefiting both the environment and the consumer. 2. Flywheel accumulate kinetic energy. This innovative design uses a coaxial rotation mechanism by a unique direct tangential force, which minimizes friction and maximizes output power with 50% less fuel consumption. Together with the rotating piston's power wheel, it creates a dynamic momentum that accumulates the energy of the inertial force, moment, continuously and completely. B, providing a driving experience with extremely fast acceleration time in a smooth way, far exceeding the acceleration ability of 63 miles an hour or 126 miles an hour of current piston engine supercars with the same total cylinder capacity. 3. Supercompressor. The compression creates all compression ratios by the torque, acting on the compression stroke according to the principle of tightening the nut, vibrator, strongly with extremely small dynamic loss. Therefore, the energy loss for the auxiliary operating mechanisms is negligible, ensuring that the engine always operates with very high efficiency continuously, completely and maximally. 4. Maximum torque moment, 100% impact of the explosion. Rotary Piston's engine. The impact force of the explosion stroke, the thrust force acting on the dynamic poles, is a tangential force, maximum 100%, and continuously creates maximum torque. At the same time, the moment of inertia continuously and thoroughly help the car achieve acceleration time from 0 to 100 km/h, 63 miles an hour, or 200 km/h, 126 miles an hour, far surpassing any supercar with the same total cylinder capacity of the current piston engine. Therefore, Nguyen's rotary piston engine has high efficiency and performance, but the monthly operating cost is very low, only at 30% of the current piston engine. On the other hand, with the principle of moment of inertia of the driving wheel in a coaxial rotary engine in general, creating a gyroscopic effect helps to balance the vehicle when entering an S-shaped curve or avoiding unexpected obstacles safely without the vehicle tipping over. Therefore, Nguyen's rotary piston engines have high efficiency and performance, but very low monthly operating costs, only 30% of current stroke piston engines. 5. Super Rotary Pistons engine. With large engines for marine engines, large motor vehicles, etc., the number of poles and the size can be increased corresponding to the design capacity according to actual requirements, and then the corresponding increase in the number of machines, pistons and cylinders of the current stroke engine is calculated according to the formula 2N2. For example, with 5 piston poles, as shown in the picture. But the engine size is much more compact than the current stroke piston engine block with 50 pistons and cylinders, because there are no giant auxiliary transmission mechanisms, such as rocker arms, sprockets with camshaft systems, exhaust valves, etc. These features make the MINH'S rotary engine both economical and environmentally friendly, positioning it as a high-performance engine design. In particular, these features allow the engine to adapt to alternative energy systems, such as hydrogen-powered engines or 2-in-1 hybrids with compressed air, or hybrids with steam, while maintaining high performance in a variety of applications. And it is obvious that with the limited range and charging stations of electric vehicles, it is completely inadequate for the needs of vessels that travel for many days at sea and on rivers. Completely inadequate for the maritime and waterway transport industry, a market with huge demand, no different from road transport. Your AI, artificial intelligence,